Okay, sorry friends. Let me start from the beginning. Okay, good evening friends. Welcome to the domain analytics sessions. We were following legal and law analytics. In the first session, we talked about some of the basic applications of legal and law analytics, how they are used in real world. Okay, so today we'll be learning more of project side. If we are working on a project for legal and law analytics, how will we go through this? So we'll be applying some project management methodology. Okay. So this project management methodology will be using is CRISP MLQ, which stands for Cross Industry Standard Process for machine learning machine learning with quality assurance. Okay, so we will see what are the various steps to follow to have or to bring out a successful project. Okay. So let's see what we'll be learning today. So today we'll be learning different stages of analytics, CRISP MLQ methodology, what is inferential statistics, unsupervised and supervised learning, what is data split, what are the various error functions related to different kinds of learnings, and overfitting and underfitting. So let's start with different stages of analytics. First stage of analytics is descriptive analytics. Okay. In this stage, we ask a question: what has happened? Okay. So we look at historical data or prior data. We look at the historical data and we analyze this and try to find what has happened. Okay. So in this stage, we get an overview of what has happened. So it also helps us make summaries. Okay, it helps us make summaries. Next is diagnostic. In diagnostic analytics, we will try to find out why. Okay, we'll try to find the answer to this question, why it has happened. Why it has happened. Okay. So in this step, we try to find whatever happens in the first step, why it has happened, and it helps us identify. Okay, in this step, we can identify the recurring patterns in the historical data, recurring patterns, and also in this step we can identify outliers. Okay, next step is predictive analytics. So here we try to find out the impact of this what on the future. Okay, So here we try to determine the future impact of this problem, okay, and how this what will change in the future. So impact of the reason, what it has on the future, we'll check impact of the reason on future, and how this reason changes in the future. Okay, so we'll also try to find out the changes with which this reason might go through in the future. Okay, so in this stage we can say this stage includes insights from both of these first two steps, descriptive and diagnostic, and it predicts future opportunities or issues. Future opportunities or issues. Okay. Last stage of an analytics, we are having prescriptive. So in this stage, we try to find how to optimize, on this problem. Okay, how to use this opportunity, or how, if some issues are arising, how to correct those issues. So here we try to make those decisions. So you can say in this step, we try to combine the insights. We try to combine all the insights of this first three steps. Okay, and here we try to create roadmap for success. Roadmap for success. Okay, here we try to give various recommendations to rectify any issues, or to make a profitable you can say business. Maybe if we are talking about business, to make a profitable business, we try to recommend according to whatever analytics we did on this historical data. Okay, so these are the basic four steps of analytics: descriptive, diagnostic, predictive, prescriptive. So to summarize here, what has happened? In diagnostic, we try to find why it has happened. In predictive, we try to find out the impact of this what on the future, and how this what changes in the future. And in the fourth step, we try to give a roadmap to success by analyzing all the previous three steps. Okay, so let's move on to the next one. So next, we are looking for all the stages, various stages of CRISP MLQ. Okay, so CRISP MLQ, let's discuss some about CRISP MLQ first. So what is CRISP MLQ? This is we can say, project management methodology. Okay, so it outlines various steps which we need to follow to get a successful project. Okay, so we need to follow all of these steps to have a successful project. This CRISP MLQ stands for cross industry standard process for machine learning, ML, with quality assurance. Okay. So let's see the various steps underlined under CRISP MLQ. So we are having business and data understanding. Then we are having data preparation. Then we are having model building and tuning. We are having next model evaluation, deployment, then monitoring and maintenance. So let's discuss a few pointers on these topics. So first is business understanding. Business understanding. So here we try to find what this business is about. So whichever business we are doing a project on, so we try to, so suppose if we are doing a business for if we are making a a project for a law firm, suppose. Okay, so first of all we need to gather knowledge on this business, what this business is about. Okay, we need to gather knowledge on this business. Once we learn about this business, okay, then we'll have to prepare a document. Prepare a document which will list out all the requirements of this project. So this document is known as project charter. Okay, this is the first step. Here we'll list out the objective of the function, the constraints of the function. Also, some of the other details we'll have to give, like what is the product description, or what is the means according to the goal of the project, what is the description. We need to tell about this. Also, project requirements. What are the requirements of our project? We need to mention this also. Third, we need to mention the summary milestones of the project. Fourth, we need to mention summary budget. What is the budget required for doing this project? Fifth, all the key stakeholders, need to mention about them. Sixth, what are the various risks involved in this project? Okay, we need to mention all this data in this project chart. Once this has been written, we need to get it signed by the project sponsor. Okay, once this is done, then we can start doing our project. So after signing of the project, we will get some data, or we need to collect our data. So next step is data collection. Data collection may be from a primary source. It may be from a secondary source. From primary source, if we are collecting data, it means we are conducting surveys or, collecting data from source directly. Secondary data is data which is already present. We are just collecting it from, suppose, online or from databases. Okay, data already present. So in primary source of data, there is an advantage that whatever variable of interest you are looking for, you'll directly get that. In secondary, you might not get that. Okay. Now primary, it may be costly and time taking. Secondary, it will be easily available, readily available. Okay, once data is collected, okay, you need to understand the data. Okay, once our data has been collected, we need to understand it. So for this, you may also want to take the help of SME or the subject matter expert. Okay. Once that step is done, you have understood the data, you have understood about the business. Next step is converting this raw data which you have got. You need to convert it, this raw data, into a format which can be readily used by the ML algorithms. Okay, you need to do some processing on this data, check for this data normality, various processes you need to do to make this data usable by machine learning algorithm. So in our case, if we are facing with a legal data, so generally legal data are in the form of documents or unstructured data. Okay, we will be having unstructured data. This unstructured data or text data, basically we are having text data. We need to convert this into a usable format. Okay, so for this we will have to use NLP models. Okay, we'll have to do text mining. Okay, various processes we need to follow. We need to do tokenization. We need to do stemming or lemmatization. Okay, we need to do US tagging. We need to find named entity. Name entities we might need to find. Okay, various processes we need to follow to convert this unstructured data to a structured data. Okay, so libraries will be using NLTK, Natural Language Toolkit. Okay, basically this will be also using either Scrappy, okay, for data mine, this text mining, or we may also use Beautiful Soup for mining of text. So all these pre-processing steps we need to follow here to make this data usable for the machine learning models. Okay, once this is done, this is completed. Okay, we need to, okay, before this, you also need to know about data. So data may be continuous data, may be discrete data. Okay, these are the two forms of data we know about. Now we may have either structured, unstructured, or semi-structured data also. So generally in legal documents, we are faced with unstructured data. Okay, structured data are those which can be found in the form of tables like databases, Excel sheets. Semi-structured are those which are having some kind of schema. Okay, like HTML. They have tags by which they can be accessed. Okay, HTML, XML. They have some kind of schema. Then comes unstructured. Okay, accessing them is very hard. We need to apply various pre-processing techniques to convert this into a usable format. Okay, once this is done, data preparation is done. Next, we move on to model building. So now our data is in the correct form. So we can use various ML models. Okay. Now this data, usable data, according to our business problem, we might do different things. So we can either do unsupervised learning or supervised learning. Okay. So in unsupervised learning, we are having various techniques which we'll be discussing in the upcoming days, like clustering, okay, dimension reduction or dimensionality reduction. We are also having association rules. We are having network analytics in this also. Network analytics. We also have NLP tasks like text mining, okay, and topic modeling. So these are the few which will be, for legal, these are the major things. NLP tasks, major tasks we are having for NLP. But this also, if our data is in the correct form, we'll use this all techniques also. Under supervised, again, we are having two things. One is classification. Another is regression. Okay. And classification, we see, so here the output value. So the difference between supervised and unsupervised is, in supervised, there will be an output value and an input value. So we find the relation between this. This relation is what our model is. In unsupervised learning, okay, there is no y. Y is not known. So here we are having just the data. We try to figure out the relation between different records in the data, and we try to group them. Okay. In classification problems, our output is in the form of a discrete data. In regression problem, our output is in the form of a continuous data. Okay, that is all about model building and tuning. After we have built our model, we need to evaluate our model. Okay, model building and tuning, we will be discussing this in the upcoming slides. Model evaluation. So here we try to find out, okay, that which model performed the best. So if you are training with multiple models, here we will find out which model performed the best. Okay, once we find this best model, okay, we'll take this, make an app. Okay, best model. We'll take this model, we'll make an app. This app can either be a web app or a mobile app. Okay, and we will deploy this either on a website or as a website or a mobile app. Once this is done, deployment part is done. Okay, your model is ready and it will be working fine. But after some days, or after a few months, or after a few weeks even, okay, we might see that our model or our app is not giving good accuracy or not predicting that much, or whatever you have made this app for, it is not doing that work correctly. Okay, this is due to change in data. Okay, the data might change in data. This is known as data drift. Okay, so we need to figure out what changes should we make in our model so that it also, figures out that with change in data, still our model should predict good. Okay, so we have to give support also after the project is done. Okay, if this is not provided, then this model or this app will not be used that much. It will die out at the end. So these are the various steps we need to follow to make and maintain a successful project. Okay, now let's learn about the various data mining techniques or machine learning techniques. Okay, so we learned that under data mining or machine learning, we are having supervised and unsupervised learning. So we discussed that unsupervised learning, why is not known. Okay, if why or the output value is not known, we try to figure out from our data set what rules exist or what are the hidden rules or patterns or trends in the data. We try to find that out. Okay, we try to find out what are the various patterns hidden inside the data set. Patterns or trends. Okay, once we figure this out, we can use these patterns to predict for new data as well, under which cluster it will fall or under which group it will fall. So here we take a historical data. We use some ML models, machine learning models, to find out the hidden rules and patterns in the data. Okay, this is the training phase. Once this rules and patterns we have found out, okay, we can apply this here with new data. Then we are given a new data. Okay, using these rules and patterns, okay, we try to predict the outcome. What outcome or in which group this new data belongs. We try to predict this. Okay, this is unsupervised learning. Then we are having supervised learning. In this case, our output value is known. Okay, we are having some input values and our output values are also known. Here we try to find out how this input values are related with the output values. Okay, so to do that and to evaluate this model, we have to take this historical data or the data set. From this data, we need to do random sampling. Okay, randomly choose few of the records for training data and few of the records for validation data. Okay, some records will be chosen for validation data set and rest will be given to the training data set. Okay, now we will use this training data set with some ML models to find out the relation between X and Y. This will be a mathematical equation. Okay, once this is found out, okay, we will then test this mathematical equation on the validation data. Okay, this is also input data. Now this input data will try to predict. Okay, using this mathematical equation, we'll try to predict the values for this validation set. Okay, then we'll check what is the accuracy with this validation set. If our accuracy is not that good, okay, we'll again retrain. Okay, here we try to tune our model. Unless and until we get a good result, we will carry on this tuning of model, or it is also known as hyperparameter tuning. Okay, once we get a good model, once we are finding a good model, we will combine both of this data and again find this mathematical equation. Okay, then use this mathematical equation on the new data to predict what will be the outcome of this new data. Okay, so here what we are doing, we are taking an input, new data, we are doing put or using this mathematical equation, then we are getting the output. Okay. Okay, so now let's see the splitting of the data, how it is done. Okay, so we saw that we had a training data set. If you saw, if you just see this, here we are doing random sampling to split our data. So how does this split work? Let us see. So we are having a data set. Okay, this data we are having, we are splitting this into 3 sets: training, validation, and test. Training set, suppose it is having 80% of the data. Validation set, suppose it is having 10% data. Testing also has 10% data. Okay. This data we have divided into 3 parts: training, validation, and test. Training data, on this we will build a model. We build a model on this. Okay. Once this model is built, we are finding some mathematical relation. We will apply this on this validation data set. Okay. And we'll find the accuracy or error. Okay. So in one of the case we'll find accuracy, in one of the case we'll find error. I'll tell you later. So here we are finding either the accuracy or the error. Okay, if we are not having that much good accuracy, we try to fine tune this model. Okay, then again this process continues. Again we fine tune this model, build a model, again test on validation data set. Okay, until we are getting a good result, we will be continuing this process. Okay, and we can also apply various different kinds of ML models to do this. Once we get a good result, okay, we'll combine both training and validation data set and run the that same model on this whole data. Okay, with finalized model parameters. So in every step we are tuning also, and we are tuning to get the best parameter settings. Once we are getting this best parameter settings, we are combining these 2 sets and finally training this on this 2 data sets. Okay, using those parameters. Once this is done, okay, we go to the testing phase. So here, after making the final model, we are testing on the test data. Now on this test data, whatever accuracy we are getting, that is known as generalization accuracy, or whatever error we are getting, that is known as generalization error. Okay. So let's discuss about some error functions. Okay. So we are having error functions confusion matrix. In this error function, we are having, this is done for categorical data. When we are having output as a categorical data. So here what we do, we prepare a chart like this, 2 into 2 matrix, you can say. Okay, this is done for a classification problem. Okay, classification problems are those which we are having Y as category. So here we are having a predicted class and an actual class. So this predicted class will be having yes, no answers. Okay, classification. So we'll be having categories here. This will also be yes, no. So here we try to find out whether our predicted is yes or no. If our predicted is yes and also actual values are also yes, we'll call this true positive. Okay. If our predicted is no, sorry, predicted is yes, and actually the classification is no, classification value is no, we will call this false positive. When predicted is positive but actual is no, that is false positive. Again, if the predicted is no and actual is yes, okay, we are predicting that it is not there, but actually it is there. This will be false negative. Okay. Next, if we are having a predicted value no and actual value is also no, these are true negatives. Okay. So here, if I want to find the accuracy, the value will be the true values. Okay. Both the true values, true positive plus true negative, by total number of values, true positive plus false positive, false negative plus true negative. All of these values added together. Similarly, error will be both the error terms divided by total number of terms. Okay. So this way we evaluate the categorical values. Okay. So there are various other measures like precision, sensitivity, which is also known as recall, specificity, okay, FP rate, F1 ratio. All these terms we are having to measure a classification or evaluate a classification. Okay. So these are the various, you can say, evaluation metrics which we can use based on the problem statement. So what we need to find, whether we need to find accuracy, whether you need to find precision, whether you need to find, F1 ratio, what you need to find. Accordingly, you will take this evaluation metrics. Okay. So let me tell you one thing. We are having a 2 into 2 matrix. Okay, this is true positive, false positive, true negative, false negative. Sorry, false negative is this, true negative this. Okay. So out of these 4 units, so let us check the accuracy. Suppose this, we are having this true positive and this added together, we are having 85% accuracy. Okay. And false positive, we are having suppose 2, and false negative, we are having 3. Okay. These two 40-40 suppose. And these are 2, 3. We are having some value like this. So out of this, we are finding that this is 85% and rest is 5% error we are having. But false negative values are higher than false positive values. So false negative values are those in which the predicted is no, but actually it is there. So suppose we are using it for a law form. We are classifying a document whether the result of that case was yes or no. Okay. So we see that our model is predicting 85% with 85% accuracy. So we say that, yeah, it is a good model. We are getting good results. But when you are talking about accuracy, we are just seeing the positive true values. Okay. We are not looking for the error values. So suppose out of these three models, okay, this document is one of them in which we are predicting no. The result we are predicting it as no, okay, but actually it has a value yes. Okay, so when we take this information to the code, okay, it will not be good. It will be not be a good case, because when we look at the actual result of the case, it was yes. Okay, but we prepared according to if the case was no. So we will not get a good result in this case. It will be disastrous. So false negative cases are disastrous, and we will have to identify this, we will also have to check for error calculation. What is the error? Okay. So it is not that only accuracy will be the prevalent, you can say, evaluation metric. Okay. According to what your requirement is, you should change your error function or this evaluation metric. Okay. Now, if we are facing a regression problem, or when our output is continuous regression, if we are following a regression problem or output, we are having a continuous value. Okay. So for this, we will have to find the error. How much our model is giving error, how much error it is giving us. Okay. So various methods by which we can find error are mean absolute deviation, mean squared error, root mean squared error, mean percentage error, mean absolute percentage error. Out of these two are the most important. RMSE, root mean square error. Okay, these are quite often used, and second one is MAP, mean absolute percentage error. Okay, if we are having a continuous value, we will use this. Now model evaluation. Okay. So here under model evaluation, first of all, we should check our model is overfitting or not, or underfitting or not. We don't want a model which is either overfitting or underfitting. So what is this overfitting and underfitting? So overfitting is a case when, okay, we are having a model which has trained so rigorously on our data that it has also learned the noisy data. Okay, noisy data meaning the outliers also it has taken as the data. Okay, or we can say the model is too complex. Model can learn complex data, but our data is very simple. Okay, if we are having a simple data, but the model learning is too complex, so what it will do, this model will also learn this noisy data in this data. Okay, simple data, it will also learn about the noisy data. So this we generally see in decision tree. Decision tree, if we apply it to simple models or simple data, we will get overfitting data. You'll see that training accuracy for this will be 100%. But when you test the data, you will find that accuracy is around 50%, 60% like this we are having. So training on training data, we are having 100% accuracy, but when we test on test data, it reduces to around 50, 60%. So it is not good. Okay, this kind of model is not good for our training. So this happens when model is too complex for the data. So what happens when the data is too complex for the model? If our data itself is too complex for the model, then what can we do? So here the model will not be able to learn this data. Okay, on the training data itself, will have a very less accuracy. Accuracy will be very less. Okay, so here graphically, if I talk about this, okay, so here we can see we are having a data like this. Okay, but when we are training our model, we are getting a line like this, straight line. Okay, so our model is not able to gather this complexity in the data. Okay, this is a non, but we are trying to find it in a linear fashion. So this is underfitting. It will not work. Now, in this case, what we are trying to do, we are having this green line as our data, but our model is too complex so that it is accommodating every data point. Okay, even if they are not in the line. So see, some of the data are not in the line, but it is trying to accommodate all the data. Okay, so this is an overfitting case. When it tries, or the model is too complex for this data. Okay, it learns everything. So if we see this, our model, if we are doing classification, our model will be training like this. So if we are having data points inside of a different, you can see this boundary, it will also go inside that boundary and try to train. Okay, so these kind of data, okay, this will say it is overfitting. Now the splitting of the data should be done randomly. If it is not done randomly, will create bias or error in the data. Okay, if you select and choose your data and then you choose some of the records, will get a biased data. This is not correct. Okay, so here we see we can either take 60% training, 20% validation, 20% testing. This we can do, or we can take 80% training and 20% testing. If we are having a large data set, okay, we'll be able to estimate error very accurately. Okay, large data set is synonymous to better estimates, you can say. And how large a data set should be? As large as possible. Okay, now let's talk about this overfitting issue. So this overfitting, here we see a statistical model is said to be overfitted when we train on it with a lot of data. Okay, the model gets trained with so much data that it starts learning from the noise itself. Okay, noise and inaccurate data entries, or the outliers, you can say, in data. Then the model does not categorize the data correctly because too many details and noise it has learned. Okay, but underfitting data, a statistical model or a machine learning algorithm is said to be underfitted when it cannot capture the trend in the data. Okay, underfitting destroys the accuracy of our machine learning model. Okay, you'll not get a good accuracy even on the training data set, let alone test. If you are not getting good result in training, no need to test it. Okay, and its occurrence simply means that our model or our algorithm cannot fit the data. Just a second. So if we are talking about legal analytics, okay, we can say that legal analytics can be divided into 5 types of, you can say this, problems. Classification. We are also having anomaly detection. We are having regression. We are having network analytics. Okay. And we are having also reinforcement learning. Okay. So last one is a high level concept. First is classification, which we discussed. Second is, so classification, we try to find whether it belongs to class A or class B. Okay. Anomaly detection, in this, we try to find if the data is weird or not. We can say in a sense. Or is the data fitting here? Or is this data does not belong here? We try to find that out. Okay. Regression, in this, we ask the question how much or also how many. Okay, continuous value, measurable value, we try to figure here. In network analytics, we try to figure out how it is organized. How is the data organized? And in this, we try to answer the question, what is to be done next? Okay, so there are many AI concepts to be used in legal analytics or being used. So right now, we are having a very unorganized system in legal analytics. We are having some startups starting some AI apps for analytics. Okay, we are having some ML models also in analytics, but everything is unorganized. It will take time to get all of this organized under one roof. So as we go along in this course, we'll be discussing some of these use cases, like what are the AI apps being used, what are all the ML apps being used, okay, how we are using NLP tasks to gather information from documents. All this we'll see. So that is it for today, everyone. Thank you for listening to me, and have a good day. We'll end our session here. Thank you, everyone.